photovoltaics. Welcome to D Creations Resources. Let's talk about photovoltaics. Sunlight, as you know, can be converted to electricity, and this has been described by the effect called as photovoltaic effect. This was discovered by a French scientist called Edmund Becquerel in 1839, so long back. And we know that sunlight is composed of photons. So if you consider particle nature of light, we know that photons are packets of energy, and the energy associated with photons of course corresponds to the wavelength of light. Now when photons strike a solar cell, a semiconductor PN junction device that we call as solar cell, I should say, these photons can be reflected or absorbed, or they can be transmitted. That means they can just pass through the cell. Absorption of a photon in a solar cell will result in generation of an electron hole pair. And this electron hole pair, when it is separated from each other across the PN junction, it will result in generation of voltage, since there is a charge separation. So this voltage will be generated across the junction, and this voltage can drive the current in an external circuit, and so power can be extracted from solar cell. So that's why solar cell is also called a photovoltaic device. So the incident aspect is photons, light, from which photo word comes. So light energy corresponding to sunlight is getting converted to electric energy, so hence photovoltaic. Now the first solar cell was demonstrated long back, that was around 50 years ago, and then year by year there has been attempts to increase the efficiency of solar cell. So we have been able to reach up to say 25% of efficiency, and of course when you want to increase the efficiency, you have to improve the electrical and optical design of the cells. Now if you passivate the contacts and surface region of the cells, and if you are able to reduce the volume of heavily doped material within the cell, you are improving the electrical design. If you want to improve the optical design, basically the reflection needs to be reduced and the trapping of the light within the cell has to be improved. So these are some factors that you need to work upon if you want to increase the efficiency of solar cell. Of course, there are different types of solar cell, or different kinds of materials can be used for it. Now a crystalline silicon wafer is commercially produced, or even thin film solar cell technologies are very much now in use, and of course they include amorphous silicon, cadmium telluride, copper indium gallium selenide, so which is the short form is CIGS, or for cadmium telluride it's CDTE, and a lot of research is being devoted to this field of photovoltaics.